The last part of statistics and probability is to use simulations to find experimental probabilities for these compound events. So let's use a coin to generate 15 trials of guessing on 2 true and false questions to find the experimental probability the student will both get them correct. So there are 3 steps when you're trying to generate your own experiment to find probabilities. Is to choose a method to model the situation and designate specific outcomes of the model to specific outcomes of the situation. Define one trial, and then conduct the number of trials desired and record in a frequency table. So using the example from above, we're going to use a coin to generate the true or false. So we're going to let heads represent guessing correctly and let tails represent guessing incorrectly. One trial is 2 flips of the coin to represent the outcome of guessing on both problems. So let's say we did this. Let's say we flipped our coins 15 times and got the following outcomes: heads, 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 tails, tails, heads, etc. Then we can fill in our frequency table to match the outcomes. So the number of who they got correct would be heads and heads. So I see that there were 1, 2, 3 where they got heads, heads, meaning correct, correct. And then we can count the rest for the remaining. Further, the relative frequency then is out of 15 trials, 3 out of the 15 were 0 correct, 9 out of the 15 were 1 correct, and 3 out of 15 were all correct. The theoretical probability then, theoretical meaning what should happen, is that if we got the first problem correct or incorrect, then our second problem would be correct or incorrect. So these are independent variables because one does not affect the other. So the probability or the relative frequency of getting 0 correct is 3 out of 15 or 20%. The theoretical probability is 1/4. So out of the 4 options that we have altogether, 1 out of 4 would be 0 correct, or number correct would be 0. So 25%. Since these are fairly close to one another, this is a good model that will work. Ashley saves 5/6 of the shots that are taken against her. Use a number cube to generate 10 trials that represent a shot against her. So steps for generating the frequencies. Let's choose the model. So since we're talking about 6 shots, we could use a number cube to do this. So we're going to let 1, 2, 3, 4, and 5 represent saving the shot, because that would be a 5 out of 6 probability. Then we'll let 6 represent not saving the shot. One trial is 1 roll of the number cube to represent the outcome of attempting to save the shot. So let's roll a number cube and see what actually happens. So on our class website here under manipulatives, I'm going to choose, move this over for us to see here. I'm going to choose this virtual manipulative. I guess we could also use a spinner that had 6 options for it as well, but let's use the number cube. I'm just going to choose this dice here. We'll click go, and it looks like up in the corner I'm able to roll. So let's roll the dice and see what we get. We got a 2. So for our 2, we saved the goal. So I'm just going to kind of keep track here. Okay, we'll go back. We'll roll again. We got a 3, so we saved. So instead now we have 2 of them. We have to do this 10 times. We have a 1, so we've saved again. So we're up to 3 under the saved goal. A 5, so we saved it again. a 4, a 5, another 5, so far so good. One, only 2 more to go here. One more. And a 3. Move our screen back in order here. So 0 times she did not save. So the relative frequency would be 10 out of 10 or 100%. Okay. We know the probability should be 5 out of 6 times, and 5 out of 6 is the same as 83%. So this was 100%, but I would still say that this is a good way to do this. You could also, again, use a spinner that had 6 options on it, letting 1, 2, 3, 4, and 5 represent saving the shot, and 6 represent not saving the shot. Although we didn't have the option of 6 coming up, remember, the more simulations you do, or the more you experiment, the closer to the theoretical probability we will get. So if we were to continue doing this, perhaps we would get a little bit closer than we already are. So your homework for this week is to print the homework file included in the Practice Problems homework Dropbox. Complete the problems as outlined within the homework pages, taking care to show all of your work. Feel free to use any of the manipulatives we have, and then scan and upload your documents back into the Practice Problems Dropbox.